In this lesson, we're going to define density and see how we can calculate density. We will also be using density later on when we start doing dimensional analysis problems because it's a relationship between mass and volume. Density equals mass over volume, and it's usually in grams per milliliter or grams per centimeters cubed. Those are the most common units we see it in, simply because it gives us values that are easy to manage. And one thing that's really important to remember is that 1 milliliter equals 1 centimeter cubed. So if you imagine a playing die from a board game, it's about 1 centimeter on each edge. And so if I took 1 centimeter times 1 centimeter times 1 centimeter, I'm going to get 1 centimeter cubed. And that's about 1 milliliter, just so you can have that in your head. And so these are interchangeable because they mean the same thing. Milliliters is a unit of volume, and centimeters cubed is also a unit of volume. Now, be aware that volume is temperature dependent. So density is also temperature dependent. If you look at the density of water at a variety of temperatures, it's going to vary slightly. We don't see dramatic changes, but it is important to know that this can affect the density because the volume changes with temperature. Most values for reference are recorded at either 20 degrees or 25 degrees Celsius. And usually we won't have to worry about looking up a different value. If it's giving you the density, we're just going to use the density as given. Now, density is a derived unit because it combines two other units. We could have the units of kilogram per meter cubed, which we based on the SI base units, but it's not always a practical unit, so we use grams per milliliter or grams per centimeter cubed. Density is an intensive property because whether I have a small sample, such as a piece of gravel, or a boulder of the same kind of rock, I'm going to have the same mass to volume ratio, so I'll have the same density. We have different kinds of substances, so water has a different density than lead. Different types of rock would have different density, but if both are the same kind of rock, so say limestone, they're going to have the same density. 2 samples of honey were removed from the jar, 1 teaspoon and 1 tablespoon. Which statement is true? So C is our correct answer. Each sample has a different volume because we had a teaspoon and a tablespoon. Each volume is having a different mass because we have different amounts of that substance. However, the density of those samples, that mass to volume ratio, will be the same regardless of how small or large the sample is of that honey. A 21.6 gram sample of a substance occupies a volume of 27.5 centimeters cubed. Find its density in grams per centimeters cubed. The first thing we need to remember is, what is our density? Mass over volume. So to solve this, we can plug in the values, our 21.6 grams, our 27.5 centimeters cubed. We can divide that, and I've rounded that a little bit here, to 0.785 grams per centimeter cubed. Let's look at another example that's a little bit different. Here we have an 18.2 gram block of iron is added to a graduated cylinder containing 26.5 milliliters of water. The water rises to 28.8 milliliters. What is the volume of the iron block? So we're not calculating the density yet, just the volume. So if we have our graduated cylinder and we say, okay, we have water up to where the red line is, then we put in our block of iron. We drop it down in there carefully. Okay, so we have our cube of iron there. And then what happens is the volume of the water raises. So what is the volume of the iron block? So this is the volume by displacement because the iron pushed the water up, and the volume of the iron equals the change in volume of the water. So we take the difference in those two values, 28.8 minus 26.5, and we get volume of 2.3 milliliters. So D is the correct answer. Same sample. We've already determined what the volume of that block is because we determined that by displacement. Now, what is the density of the iron block? Again, we know that density equals mass over volume. We plug in our mass that was given, the 18.2 grams, the volume we calculated on the previous problem, 2.3 milliliters, and then we can solve for the density of 7.91 grams per milliliter. So we have C as our answer.